Welcome back to my channel, everyone. 3 tips here. What I have is some bangle type bracelets that they began to break, and the jeweler repaired it a couple times, but then he just told the owner that they're beyond repair. It's just time to scrap it out. These are marked 21K. And so what we're going to try to do in this video, let's see what we got for a weight on this. It's 30.7 grams. What we're going to do is take this out and refine this into pure gold. Small shot of sulfuric acid, take care of any lead that may be present. It's got some color to it. I'm going to stick a little piece of filter paper in here, some of the solution on a piece of filter paper. We're going to test it with stannous, see if we've got any gold in solution just by adding the hydrochloric acid. I don't see any evidence of that. I don't see any gold in solution. I'm going to add just a little bit of heat here. And now what we'll do is put in some small shots of nitric acid. This is almost an ounce of gold, so it might take about 30 milliliters of nitric acid to get all that metallic gold to dissolve. I'm going to put it on time lapse. Commence doing that right now. Dissolving metallic gold takes a little bit more nitric acid than dissolving just the powder. So in this case, I added some additional extra nitric acid, and then I just evaporated the solution down until all the fumes were gone to drive off all the excess nitric. Got this evaporated down, and all the excess nitric has been driven off. I'm going to pull this down now off the heat and let it cool down. Notice how this solution looks almost black. And notice as I drop the ice in that a cloud of silver chloride forms around the ice as I drop it down into that solution. Plus it turns a lighter pale shade of green as the solution gets diluted by the ice. Silver was in that alloy, in that 21K gold. You can tell because the solution is very cloudy. And also, as I pour the solution out of that beaker, you can see solid silver chloride being rinsed out of the beaker down into the filter. Here you can see our solution is just a touch on the cloudy side. That's probably a little bit of silver chloride still suspended in that gold solution. In this footage, I'm going to use some SMB, sodium metabisulfite, to precipitate out the pure gold. I'm going to start by adding just a few grains of it in tapping it in off the spoon, off the rim of the beaker. And that solution is green because we went straight to Aqua Regia with the 21K gold. 21K gold is about 87% pure gold, and the rest is probably going to be copper in the alloy to give it some strength, and that's what has turned our solution a green color. Gold in solution is yellow, copper in solution is blue, blue and yellow make green. Here I'm trying to adjust the light, get the lighting just right, and I had it on a pedestal and couldn't quite get it adjusted properly. Finally got it, and now we're going to add another spoon of the sodium metabisulfite in, and you'll see the cloud of pure gold coming out of solution from that green liquid. Now what we'll do is get a stannous test on this liquid to make sure all the gold is dropped out of solution. As you can see by this negative stannous test, all the gold has in fact been precipitated. Got the gold to settle out completely. Now what we'll do is rinse it off with distilled water. What I'd like to do is take a moment for a little public service announcement for my channel. There are folks who are asking me questions via my eBay messaging system, and I cannot answer questions about refining or about buying or selling material on my eBay messaging system. So please do not ask questions about refining on my eBay messaging system. If you do, I can't answer them. I'll just have to delete them. It's best to ask questions in the comments section of each of the videos. I try to read all of the comments, and I will try to answer your question in the comments section on my YouTube channel. Thank you. Now we'll rinse it over and over with some hot distilled water. Silver chloride is slightly soluble in water, more so in hot water. So I use hot water rinses here, hopefully to dissolve any traces of silver chloride that might be in there with the gold and pour it off into my waste container. Plus, it should rinse off any excess SMB also. Now what we'll do is add some hydrochloric acid to the gold here. See if I can get the light on it. Hydrochloric acid. Now we'll put this up on the heat. Let it boil in the hydrochloric acid for a few minutes. These hydrochloric acid boils seem to do a good job at cleaning the gold. You'll notice that after the boil is complete, the gold will be a different color. Plus, silver chloride is soluble in hot hydrochloric acid, so any traces of silver chloride should get dissolved with these hydrochloric acid boils. Alright, look at that gold. It's just beautiful. These are hydrochloric acid boils. Get the gold looking real good. So now what we're going to do is pour this off to our waste container up here. These hydrochloric acid boils and rinses do a much better job at rinsing off any dissolved metals that may be present with the gold, better than just plain hot water. Alright, now what we'll do is prepare some more hot water and give it some multiple hot water rinses. Okay, well, there's no chemical reaction here. I think it's important to rinse the gold with lots of hot water rinses. This is important in getting the gold clean. The more we rinse, the cleaner the gold will be. All right, here's what the gold looks like. It looks awesome. I mean, it's nice and clean. Let's go ahead and add a little bit more hydrochloric acid. stick this back up on the heat over here. I'm going to put in a little shot of sulfuric acid. Take care of any lead that may be present. Now what I'll do is add a little bit of heat. Start putting in small doses of nitric acid. I'm going to get this gold to dissolve the second time. I've added 350 milliliters of hydrochloric acid to the gold, added a little heat, and now what I'm doing is dropping the nitric acid in a little at a time so that I can carefully control the amount of nitric going in, adding just the exact right amount to get the gold to go into solution. If I do this correctly, then I won't have to denox the solution because there won't be any excess nitric in there that must be removed. Here I'm adding ice to dilute the solution, to cool it, and to precipitate out any silver chloride that might be dissolved in that solution. Silver chloride is soluble in aqua regia a little bit, and so by cooling it down with some ice, it'll cause it to precipitate out of solution, and then we can filter it out completely. Here our solution is clear and bright. I don't see any traces of cloudiness due to silver chloride, and that is a testament to how effective the hydrochloric acid boils and the water boils are at removing silver chloride from the gold powder. I could tell by the color of the gold before we dissolved it this second time that it was high purity gold. I probably could have went ahead and just melted it after the first refining, but I wanted to go ahead and give it a second refining. If you notice, the solution is not green anymore. Look how clear that is, man. Clear and bright. That's a indication that we've got some high purity gold there. But you'll notice the solution is not green anymore. That's because we've got all the copper out of there when we did the first refining. So now all we should have, is gold in solution. And in my opinion, this is a waste of a filter paper, but we're going to follow the protocol and filter the gold after we dissolve it. Ferrous sulfate to precipitate out the gold. Here we go. Here I wasn't quite sure if I had enough ferrous sulfate to precipitate out the gold, and turns out I did not. I decided to take the chance and see if I could get it to come out of solution with just the ferrous sulfate that I already had dissolved in that flask, but it turns out it wasn't enough. Do a Stannis test. And you can see by that stain, there's still lots of gold in solution. I didn't have enough ferrous sulfate, so I have to prepare some more so I can drop the rest of this gold. Dumped about 150 grams of ferrous sulfate into this beaker. Got it on some heat. Dissolving it in distilled water. What I'm going to do now is add some hydrochloric acid and get this to turn green. It's important to filter this ferrous sulfate solution before we use it to precipitate the gold, because it can contain tiny bits of iron and other trash. So we want to filter all of that out of there so we got a nice, clear, bright, green solution before we use it to precipitate the gold. Pour this back through the same filter a second time. A bit cloudy. I've got the ferrous sulfate filtered twice down in this flask. I was going to try to finish this up yesterday evening, but then it got late. It took me about an hour and a half to get this stuff prepared. Should have had it done ahead of time. That's what I get for taking a chance. Just double check, make sure we've got gold in solution. As you can see by that dark stain, we still have gold in solution. So now what we'll do, move this out of the way. We've got use a stirring rod. Try pouring the ferrous sulfate right in here. earlier. Hope I don't run out of room. But here we go. We're going to add ferrous sulfate into our gold solution. So we get the rest of the gold to come out of solution. This is stir. Let's get in here, get another status test. Let's see if we've got all the gold come out of solution now. There you go, negative status test. Means all the gold has come down. Now what we'll do is pour off this waste solution into my waste container. Now what we'll do is rinse the gold off over and over with some hot distilled water. I've rinsed 5 or 6 times with hot distilled water. You'd think that all the ferrous sulfate will be rinsed off of there. Well, watch what happens when I add a little bit of hydrochloric acid. Here we go. Rinse with hydrochloric acid. As you can see, we thought we had all the iron rinsed off of there, but as you can see by that yellow color, the water doesn't get it all off, and that's why we rinse with the hydrochloric acid. Hydrochloric acid does a better job at rinsing dissolved metals off of our gold than just plain hot water. And what I'll do is pour this rinse off, this hydrochloric acid, to our temporary waste container, and we'll give it one more quick cold hydrochloric acid rinse. See, it's still a little bit of a tint of yellow color to it. And let's put some hydrochloric acid in here now. I'm going to put it up on some heat and let this boil for a few minutes. And some hydrochloric acid. Pour off this waste solution now. Alrighty, this gold looks spectacular. It's probably 3/9 fine, ready to be melted just like it is here. But I think we're going to go through one more process just to make the video a little more interesting. I've got a round bottom flask set up here on my stir plate, and I've got the ring stand supporting everything with a brick on it. We're going to begin by measuring out 150 milliliters of distilled water and pour that into our flask. got some chlorine tablets that I got at Walmart for swimming pools, and I chopped one up and I put it in this jar. So now what we're going to do is add a stir bar, turn the stir plate on. Now what we'll do is add some of this crushed up swimming pool tablet. Stuff has a tendency to kind of harden up when it gets in contact with the water. So I'm going to reach in here and stir it up and make a slurry. My main concern here is is this enough to complete the experiment that I intend to do? Our hydrochloric acid, just a vented delivery funnel, clip on the top of this thing. We'll set this up here. Put a clip on this. Got a little outlet. Put into this third neck of the flask and clamp that down. Drop it in a stir bar. Cover this up. Turn the stir bar on. Got my chlorine gas generator set up here. The hydrochloric acid, crushed up chlorine tablets in a flask. I've got a little nipple coming off of there, going to a tube, a delivery tube in my beaker. So now what we're going to do is go ahead and start dripping a little bit of the hydrochloric acid down into the chlorine gas generator and start making some chlorine gas. I'm starting to crank out some chlorine gas. You can see it forming back in that beaker. So now what we'll do is we'll turn our beaker, put our beak up here, facing backwards. We're going to insert the tube now down into the beaker and see if we can dissolve this gold by bubbling chlorine gas into this beaker full of gold. I don't have much experience using chlorine gas to dissolve the gold, and I wasn't sure how much of the reagent I should add to that flask. And my concern was that I would run out or expend the reagent before all the gold dissolved. The exact thing that I did not want to happen has happened. The reagent in the gas generator has become expended. So now what I'm going to have to do is take this all apart if I want to continue and recharge the gas generator with some more chlorine tablets. Looks like we got some of the gold to dissolve. Now what we'll do is get in here with a piece of filter paper and do a quick status test. See if we've in fact put any of our gold in solution. There you can see it. We've definitely got gold in solution. This time I'm going to put twice as much in. Some stirring. No room to maneuver in here. Let's start dripping some hydrochloric acid down into our gas generator. Start generating some chlorine gas. used up all the hydrochloric acid out of the delivery funnel. We've got the gold just about fully dissolved. Just a little bit left down at the bottom of the delivery tube down there, bottom of the beaker. We're going to add a couple of drops of sulfuric acid, just in case we got any lead in here. Just a little bit of gold left in there. You see it floating around on the bottom of the beaker. I think what we might do here is just add a little bit of heat. I'm going to add a little bit of nitric acid, maybe a half milliliter. Let's see if we can get the rest of the gold to go into solution. That half milliliter of nitric acid. Got the rest of the gold to go in solution for us. What we're going to do is pull it down off the heat. Let this cool down. I take that back. Still got a little bit of gold that has not dissolved yet. Put this back up on the heater. Let's start the stir bar. And I'm going to add just a little bit more nitric acid. Maybe another half milliliter. Like that. Put it right on in and let's see if we can get the rest of this gold to dissolve. I got to thinking maybe all of the hydrochloric acid has been expended from this reaction. So I'm going to add in just a little bit more hydrochloric acid to help dissolve the rest of the gold. Got a little bit of fresh nitric and fresh hydrochloric. Got everything to go into solution now. And as you can see, there's some fumes going on, so we'll just go ahead, let this stay on the heat, and cook off the extra excess nitric that might be in there. Okay, all the fumes have cleared up in here. I'm going to go ahead and pull this down and let it cool off. Okay, this is a clear and bright solution. If I've ever seen one. Let's go ahead and get it out of here and get this into a beaker. Look at that beautiful gold solution. Just absolutely stunning. Triple refined. We're going to transfer it into our beaker now. Here we go. We're going to use our old friend Stump Out by Bonide, which is sodium metabisulfite. Just going to throw a spoon of it right on in. Here we go. Here we go. Let's get this focused in on this thing. All right, here we go. Boom. That's highly unusual. Looked like it went clear there for a second. Let's get in here and get a Stannis test. A bit of it on a piece of filter paper just to verify we've got gold in solution. can see, dark stain means gold in solution. Like that little blob of spill up right there. Put that in my paper storage. Now let's add another spoon of SMB. See if we can get this thing done. That's 2 spoons right there. We should just about do it. I'm going to put one more just to make sure we've got everything kind of solution here. Let's give it a little swirl to mix it all up. All the gold has been precipitated. Let's do some ciphering here. 21K divided by 24K is 0.875 or 87.5%. pure gold. And we started with 30.7 grams. So we're looking at a yield of 26.8 grams. Here's our little bar that we just refined, triple refined. And I must say, this one came out pretty good, man. I mean, it's a smooth surface on that bar. I think the key to getting a good pour like that is to heat that mold up real good before we pour the molten gold in. All right, we're expecting 26.8. Let's see what we actually got for a yield here on those bracelets. 26.3. So we're off by half a gram. That's okay. I should have that out in my waste containers out there, and we'll save it up and recover it later on in a future video. We proved that we can dissolve gold with chlorine gas. Wasn't very efficient, but we pulled it off. Okay, this will conclude the video. I'd like to thank everyone for watching.